right, let's see what's going on. Section 9.3, arcs and chords. All right, so when both endpoints of a segment are on the circle, we know that that is identified as a chord. All right, the arc created by that chord, all right, RS. All right, so you just have to know the difference. All right, now they're going to give us some special properties, all right, for these arcs and chords. All right, so in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. All right, we can give you a quick little example of this. All right, here's my circle. All right, here is a chord. Here is the center of my circle. And if I am perpendicular to that chord, guess what's true? If this is a right angle, what happens to the chord? What does it look like? It gets bisected, correct? And that's not a difficult thing to prove because we can remember back in the good old days. All right, these were both radii, correct? So they agree with that. Those are equal. So they agree. This right here is perpendicular. This is reflexive. All right, we could also say because the two radii are equal, these angles are equal. So it's easy to prove those triangles are in fact what? Congruent. Therefore, the that chord is bisected. All right. So again, remember I told you in this chapter is just a bunch of rules. You have to remember all the rules. All right. I don't really think it's necessary to try to remember all the rules because we can just prove them quickly if you are ever unsure about a rule. All right. So if in a circle, if a diameter or a radius is perpendicular to the chord, then it bisects the chord and its arc. And if we extend this out, that's what they're trying to tell you. This arc is equal to this arc. All right, the next one that's kind of important. In a circle, the perpendicular bisector of a chord is a diameter. All right, so no matter what, if I can draw a circle and I am able to draw a chord, if I can calculate or if I can find the perpendicular bisector of that chord, this right here, this, then that's automatically a what? What is this automatically? That's automatically the what? Diameter. All right, that's what they're telling you. All right, so keep that in mind. All right, in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So what are they trying to tell you? If OX, right here, if you're looking here, if OX is equal to OY, then RS must be equal to what? AB. Same situation, if I try to duplicate that over here. Oh, I'm having trouble today. If I'm duplicating, trying to draw the same exact, if I measure from here to here, and I say that is all of those, well, let me just make this a Z. OZ, if I say OZ is equal to OX, then this chord up here is equal to all of these chords here. All right. Anybody have any questions with that? Anybody? Now, something I don't think maybe I did a very good job explaining. The distance from a point to a line is always perpendicular. All right. So what am I saying? From here to here, is that the distance to that? No. But as soon as it becomes what? Perpendicular, we say that's the distance. All right, that's the distance. The shortest distance from a point to a line is the perpendicular. All right, that's why they call that the distance. All right, I wish there was something more difficult than that. That's it. That's all there was. All right, so let's look down here at the problems. All right, I need some help. All right, which means I need your calculator out. Someone tell me what arc ST is. Variable wise, what is this arc? Somebody tell me. I'm listening. X, most definitely. That is X degrees. So now everybody needs to calculate X. Tell me, how did you get that?
360 minus 64 divided by 2.
And what is that again? Who doesn't know that? 148 degrees. Everybody's good? All right, let's come over here. All right, everybody write down what they think X is for number 2. That one doesn't require a calculator, don't think. What is X? How many degrees? Anybody? You may want to take a guess at it.
116.
Yeah, of course it's 116. How do we know it's 116?
There's 2 lines.
We'll call those chords. The 2 chords are congruent. Therefore, the 2 arcs are congruent. So arc DE is how many degrees? 116 degrees. This is referred to as a central angle. That central angle is the measure of the arc. So that's how they got 116. Anybody having problems with that? Anybody? All right, let's take a look at number 3. How much? 82 degrees, correct. The arcs, or I'm sorry, the chords are both 4. Therefore, the arcs are equal. All right, let's do 4 quickly. How much? 135 degrees. Remember, you got to do it. You have a calculator. Come on, chop, chop. Don't just write down 135 degrees. What?
I'm confused. How did you get?
How many degrees in a circle?
360.
Okay. So we have 90 degrees already, correct?
Yeah.
So the other 2, so if that's 90 degrees, then how much is it going to be from here to here?
Oh, so it would just be 270
And then,
divided by 2.
wow, there we go. That's easy. Easy as that. All right, check out number 5. Somebody said 7. Anybody agree with that?
Yeah.
All right. Okay, let's take a look at number 6.
2.
Somebody said 2, guys. Anybody following along with us? X equals 2. Right, 5x minus 5 equals 2x plus 1. Hopefully you're practicing your mental math. All right, you should be able to just write that answer in. All right, hold up. All right, let's go ahead and look at 10, 11, and 12. So it said circle P, the radius is 13. Now, a lot of times, these questions are on the SAT and the ACT. All right, and this one is particularly tricky because a lot of times it's necessary, not always, but just keep this in mind for test purposes that will be coming up. Sometimes you have to draw in the radius. All right, does everybody see that? So that right there is a radius. So PR is how long? Help me, guys. 13, right? PS is also what? 13. RS is what? TS is what? 12. So what is PT? 5, because we remember our what? We remember our triples. All right, 5, 12, 13. So this is 5. Come on, stay with me. TQ then must be what? What's TQ? 8, someone said. Is that true? Because PQ is how long? Because it is a what? Yeah, that's what I'm saying, guys. These are going to be on the test, right? You've got to learn to draw things on circles. All right, so you can see it. That was hard. All right, that was very hard to do. All right, if you don't draw PS or PR, you probably can't do that problem. All right. Anybody have any questions with that? That was very difficult. RT is how much? 12. PT is what? TQ is 8. Okay, let's see if I can help you with 13, 14, and 15. All right, so in my opinion, you should go ahead and write in these things. The diameter is 12. Now, I don't really like the diameter being 12, so I'm going to call AB how much? 6. That's how I would handle it. AB is 6. CD is 8. Because CD is 8, that makes FD and FC what? 4. So here we go. I'm going to put 4 here and a 4 here. Arc CD is 90. So what's true about CE and ED, those arcs? Yeah. See how I like to just break it down as much as I can. 45 and 45. So once again, I'm drawing AD. What's AD? AD, come on now. The hardest thing is to look at it and determine the radius and the diameter, right? So AD again is what? AC is also what? 6. That's what you're supposed to do. All right, that's what you're supposed to do. Now, just for us, somebody tell me what is arc CB? What's this arc over here going to be? What's arc CB, guys? On how much? 135 degrees. Same people are telling me the same thing. Come on, speak up. Then BD would just be what? 135. All right. Now, I know they're probably going to ask me about, oh, maybe they won't. Oh, yeah, AF. All right. I need to know what AF is. Now, we're practicing 6 and 4 has a common what? And we're doing A squared plus B squared equals C squared, correct? So everybody should be able to look now and say AF is what? You should try to do it mentally. What is it? What is it? Definitely not. It has a common what? What first of all, common 2. So everybody should write down 2. Now you're doing Pythagorean theorem with 3 and 2. So it is again, what is it? 2 radical 5. Now you can speak up and say, man, I don't know what you're talking about. 2 radical 5. You good? So do we agree we're doing Pythagorean theorem with 4? We're missing A, and we have the hypotenuse 6, correct? So this is 2 times 2. This is 2 times 3. So this is going to be 2 times something. That something is a result of the Pythagorean theorem with 2 and 3. 3 squared, 2 squared, 9 minus 4. There you have it. 2 radical 5. All right, so now the hard one. Someone please tell me what FE is. FE is equal to. Come on, people. What is FE? Exact answer for FE. Exact answer. Thank you, sir. 6 minus 2 radical 5. Anybody have any questions with that? Since only one person told me the answer.
How do you get to that?
What can you tell me what AE is?
That's-
What if I told you AF was 1? What would FE be? So AF is how much?
um, You have,
So FE is what?
oh, so, oh, that.
Yeah, you see it now, right?
Yeah.
There you go. Nice. Anybody else? Not sure. It's just the whole minus the part. That gives you the other part. 6 is the radius, and we're subtracting out whatever AF is. And AF happens to be 2 radical 5. That was a good problem right there. All right, let's just jump to 32. We'll do some of these harder ones down here, and then you can go back and do the easy ones. All right, here we go. Let's look at 32. For security purposes, a jewelry company prints a hidden watermark on the logo of all its official documents. The watermark is a cord 0.7 centimeters from the center of the circular ring that has a 2.5 center diameter or radius. To the nearest tenth, what is the length of the cord? All right, I'm waiting for this. Let's go. Figure it out. Just watching some of you. What's the first thing you should put on your paper? What should we draw? Try drawing a circle. That's the beginning. All right, you're not supposed to sit and look at it and say, oh, that's obvious. Draw a circle. All right. Come on, this is how you get better at these problems. Drawing a circle. Now it says that there is a cord 0.7 centimeters from the center. So I'm drawing the center of my circle. That's the center. I have a cord. I'm drawing a cord. Here's, that's not my cord. Here's a cord. Now, what I'd like for you to do is that cord is 0.7 centimeters away. All right. So here we go. 0.7 is here. What angle is created? 90. And it has a radius of what? So how am I going to figure this radius out? I need to draw something. Yeah, I mean, guys, this is what I'm saying. You're going to have to do the work on it. You got to draw from there to there. How much is that? 2.5. Now I'm missing this. Right, that's the only way you can do this, guys. You got to draw all the pictures. All right, I'm listening. I want to know what's the length of the chord. All right, and we'll round it to 3 decimal places. Oh, we don't even need to. Come on, stop using your calculator. Stop using your calculators. Look up there on the board. Look how sneaky these guys are. Come on.
Oh, 2.4.
What? Yeah, why?
Against-
Yeah, they're all over the place. If you can think about it. What's the triple again, Liam? 7, 24, 25. Is everybody with me? So if it's 0.7, 2.5, then X must be what? 2.4, which means that the chord is what? 4.8. All right, 4.8. So again, just to make sure, everybody can write them down again if you forgot. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. These come up in all the word problems, all of the SATs, all of the ACTs. All right, if you know these triples, they're very beneficial, can save you a bunch of time and a bunch of trouble. I don't think that's a big deal. All right, let's look down here at 34. Which of the following is a valid conclusion? All right, so I know that TQU is equal to RQS. Do we agree with that? So because of that, what's true? Let's don't look at our answers. What must be true just based off of that information? Someone tell me. RS, everybody put a little mark here and a mark here. What else must be true? R what? Yeah, those are equal because these are all what though? Radii, correct? So he can say all of these are equal. We know that because those are all radii. What else is true? Tell him.
The RS is congruent to TU.
Yeah, RS is congruent to TU. Does it look like RT is congruent?
Yeah.
Right? Kind of looks like they're all congruent, correct? But can we say for certain that they're all congruent? No. So which one of those facts are true? 1 and what? Is that right? 1 and 3? Yeah. All right. I kind of feel good about that. All right. Is everybody, I'm just trying to show you guys, you're going to have to draw the picture sometimes. All right. Anybody have any questions? I think that's good. You guys should be able to knock this out. All right. Yeah, I kind of look things over. I don't think it's too bad. All right, that's your homework now, guys. Knock it out right now. Let's go. Get to work. Finish it up. Try to get out of here with no homework.